This week we're going to review factoring. And we're going to talk about all the different types and ways we can factor. The first one we're going to look at is the greatest common factor, which is often referred to as the GCF. Okay, remember the GCF is the largest number that can divide every term in the polynomial. So if we look at this, we have 20x cubed plus 68x squared plus 40x. And our largest number that can divide all of these would be, let's see here, 4. Okay. And then in our variables, we look at what is the lowest exponent. So here, x to the first is the lowest. So 4x is our GCF. And then when we factor that out, we're going to divide. So 20 divided by 4 is 5. X cubed divided by x. Remember, we subtract our exponents. So we have 5x squared plus 68 divided by 4 is going to be 17x. And then 40x divided by 4x is 10. Okay. And since it just asked us to factor out the greatest common factor, that would be our answer. Remember, we can always check by multiplying. So here, if we took that 4x times 5x squared plus 17x plus 10, we would distribute and multiply. So 4x times 5x squared is 20x cubed. 4x times 17x gives us the 68x squared. And 4x times 10 gives us the 40x. So that ensures that this answer is correct. All right, example 2, factor a quadratic trinomial when a equals 1. So depending on who you had as a teacher, you did this different ways. I'm going to show you the shortcut whenever a equals 1. Okay, so first thing we're going to do is look at our C value, which is 33. And we want to find all the factors of 33. And the key thing is we're looking for something that multiplies to be 33, but adds to be negative 14. So for 33, we could say 1 and 33. But if we add those together, we get 34. So that doesn't work. We could do 3 and 11. Add those together, that gives us 14, which is close, but we need it to be negative. So instead, let's try negative 3 and negative 11, which will give us the negative 14 we needed from the middle. So now that we've found those two factors, we can jump straight to our answer, which is why we call this our shortcut when a is 1. So we would just plug in, we have y, because that's the variable we were given. And then we're going to plug in those two factors, so negative 3 and negative 11. And that is your answer. And here, if we wanted to check this, again, we would multiply. And when we multiply a binomial times a binomial, remember that's called FOIL. So if we FOIL, we have y times y, which is y squared. Y times negative 11 is negative 11y. Negative 3 times y is negative 3y. And negative 3 times negative 11 is a positive 33. If we combine like terms, we have y squared minus 14y plus 33. So that proves, since that's what we started with, that that is our factored form. Okay. All right, example 3, factor a polynomial by grouping. So we do this when we have 4 terms. Okay, and we're going to actually use factor by grouping when we do AC factoring. So that's why we're going to review it. And actually, now that I'm looking at this, I fixed this on your guys' worksheet, but this should be a minus r, not a plus r. So factoring by grouping means we group the first two terms and we group the last two terms and we look and see what's the GCF. So the GCF is what we're going to use. Okay, so our GCF of 8QR minus 8Q is going to be 8Q. And then we divide. So 8QR divided by 8Q, all you're left with is R. Minus 8Q divided by 8Q is 1. And then we have negative R plus 1. So remember, whenever we have a negative in front, we're going to factor that out. And since our other factors of R and 1 is just 1. And then divide negative R divided by negative 1 is R. And 1 divided by negative 1 is negative 1. So the key thing here is that we want to make sure our parentheses match. Okay? And since the parentheses match, that can go and be one of our binomials. Okay? And then we take whatever's left on the outside. So 8Q minus 1 is another one of our binomials. So that R minus 1 times the quantity 8Q minus 1 is our solution. And again, we can check by foiling. Okay, so just like what we did in example 2. All right, example 4. So factor a quadratic trinomial when a does not equal 1. So this is when we're going to use AC factoring. It's very similar to what we did in example 2 and 3. We're going to kind of combine them together. So if we take A times C, that would be 12 times 5. Remember, we only look at the numbers. We don't include the variables, which equals 60. And we're looking for the factors of 60 that will add to be 23. Okay. And rather than writing our whole list, those factors are 20 and 3. Now, since A is not 1, we cannot jump to the shortcut. Instead, we're going to rewrite this as 12y squared plus 20y plus 3y plus 5. Okay, so we basically split the trinomial apart so that way it's a polynomial with 4 terms. And since we have 4 terms, now we can factor by grouping like we did in example 3. So if we look for the GCF, 12y squared plus 20y, okay, 12 and 20 are both divisible by 4, and they both have a y in common. So if we divide 12y squared divided by 4y, we're left with 3y. And then 20y divided by 4y is 5. Looking at the second grouping, 3y plus 5. 3 and 5 are not divisible by anything other than 1, so our GCF here is 1. And if we divide, we're left with 3y plus 5. So our parentheses match. So that is our first binomial. And then our second binomial is anything that's left on the outside. So 4y plus 1. Okay. Looking at B, we have 12x squared plus 26x plus 12. So we should do AC factoring here, but remember we should always check for a GCF first. Okay, that should always be your first step of factoring, no matter which method you're using. So here, if we look for a GCF, 12, 26, and 12 are all even, so we know they're all divisible by 2. So we have 2 times the quantity, 6x squared, plus 13x, plus 6. And then do your AC factoring with this trinomial on the inside. Okay, so now AC would be 6 times 6, which equals 36. And our factors of 36 that add to be 13, which would be 9 and 4. And so we're going to leave this 2 out front. And then we're going to replace the 13x with 9x plus 4x. And then group your first 2 on the inside of the parentheses and your last 2. So again, the 2 is just hanging out front, so we don't forget it. 6x squared plus 9x, our GCF, is 3x. And if we divide, 6x squared divided by 3x is 2x. And 9x divided by 3x is 3. Looking at our second grouping, 4x plus 6, the GCF there is 2. And if we divide, 4x divided by 2 is 2x. And 6 divided by 2 is 3. Our parentheses match, so we can write that out front, 2x plus 3. And then we're left with 3x plus 2. And then make sure you're careful to bring that GCF down and put that in front as well. So 2 times the quantity, 2x plus 3, times 3x plus 2 is your solution. Alright, the last method we're going to talk about for factoring and reviewing is the difference of squares. So remember, we have to be subtracting, and we have to be able to take the square root of both terms, and then we can nicely just go straight to our answer. Okay, but again, remember your first step of factoring is always your GCF. Okay, so if we look at A, we have 8t to the 4th minus 72. If we try to take the square root of 8, we get a decimal. So this is an example where we have a GCF. And if we look at 8 and 72, we can divide both of those by 8. If we do that, 8t to the 4th divided by 8 is t to the 4th. And 72 divided by 8 is 9. So now we're going to look at finding the square root of t to the 4th, which is t squared. And we find the square root of 9, which is 3. And once we know these two numbers, we can write our binomials. T squared plus 3 and t squared minus 3. And then be careful, remember to bring down that GCF to put in front. And that is your solution. Okay. And lastly, let's look at B, 12x squared minus 27. So we can't take the square root of 12, so it means we should check for a GCF. So what can divide 12 and 27? And that would be 3. We're left with 4x squared minus 9. And then check, can we take the square root of 4x squared? The square root of 4 is 2, and the square root of x squared is x. And then can we take the square root of 9? We get 3. So we can write our two binomials, 2x plus 3 and 2x minus 3. And then bring down your GCF. And remember, you can always check your answers by multiplying and seeing if you get back what you started with.